Okay, 21. So use a linear or exponential model to solve each real-life problem. Feel free to use a graphing calculator if you need to. So the population of Salt Lake City was 160,000 in 1990, and it's been growing by about 0.8% per year. So first, remember to go from decimal to percent. It's always 2 times that you move the decimal. When you don't see a decimal, it's always at the end. But from D to P, you move the decimal to the right. To go from a percent to a decimal, you move the decimal to the left. So this is a percent. So what I want to do is take this 0.8, since I'm going back to decimal, move it 2 times. So that is my decimal version, just so you know. And use an equation to predict the population in 2020. So it's growing. It's exponential, because that percent. My initial amount is the 160,000. And so let me go back to this. So G, remember G is, since it's growing, I'm going to use 1 plus R. So I'm going to take 1 plus this decimal amount here. So no M. Now I'm going to use my equation. So Y equals my initial amount, my y-intercept, and my new growth rate. And I'm going to put X, I'm actually going to put T here because this T is time, X is time. So from 1990 to 2020, well that's 20 years. To go from 1990, no, 30 years. 1990 to 2000 is 10 years. So to 2000 to 2020 is 30. So I'm just going to my calculator. Any calculator will work here, you guys. You do not need your graphing calculator, but I'm going to type it in. And then my exponent key, all of them will use this button. And I'm just, this is people, so I'm going to round to the nearest person. So that 7 is going to make the 5 round to a 6. So 203, 206. So 203,206 people. All right, next one. A plane's flying at a cruising altitude of 30,000 feet. It descends at a constant rate of 1,100 feet per minute. Use an equation to determine when the altitude of the plane is 10,000 feet. So this is linear. I don't see a percent. It's constantly going down at 11,000. If you think about a plane, it's going to descend like this. Okay? Well, maybe a little flatter than that. So this is linear. My initial amount is the cruising altitude of 30,000 feet. There is no G, sorry. M is, this is my rate. It's going down. So this is technically, since it's descending, negative. And my equation, so it's Y equals, I'm going to actually put the B, the starting amount first. And then it's going down, so I could subtract or I could add the opposite. So with it should be when the altitude of the plane is 10,000 feet. So that 10,000 is not going in here. Y is the altitude, so it's actually going to be my new amount. And I'm going to solve for X. So the first thing I'm going to do is move the 30,000 over. I'm going to subtract. So I'm going to move down here. So you get negative 20,000 equals negative 1,100 with that X. And now to get X by itself, I'm going to divide by negative 1,100, which I don't have room to write that, but on my calculator, I'm going to take negative 20,000 divided by negative 1,100. And there is my, right, 1,100. And there is X. There's my time. And this is per minute. So that amount is 18.18 minutes, so about 18 minutes. Okay? Okay, wrapping this up, question 24. So you're tracking the population of a herd of bison and you've collected the data in the table. So they want us to create an exponential equation that models the population of the bison herd and then predict the bison population after, 50 years. So first I can go from we know it's going to be exponential, sorry. The y-intercept is 100. There is no M in G. So on G, you guys, we have to be really careful because I have to be able to pick a Y and pick its previous Y, which means the X's have to go in order. So I can't work with 1, 16, and 100, because 0 and 3 are not, 0, 1, 2, 3. I'm going to have to work with these two, because if y is 122 and its x is 4, here's the previous y that goes with it. So I'm going to have to use 122 as the y over the previous y. Whoops, I just wrote 112. So when I type those into my calculator, my r is going to be I'm going to round it to 2 decimal places. That's my r as a decimal. So what is that as a percent? Well, remember, going from a decimal to a percent, I'd go to the right. So the percent is going to be 105%. And then to find the growth factor, I take 1, because it's increasing, 1 plus that 1.05. So my growth factor is going to be 2.05. So here's my equation. Y equals B times my growth factor, and I'm going to use T for time because X doesn't really work. So now I'll put 50 in there. So putting 50 in there into this equation, so 100 times, and then you can do parentheses, and I'm going to put 50 in there, and I get let's just say 3.9 years. And again, I just put 50 into there into my calculator and rounded. So I got this one started. So it's exponential because it's decaying at a rate of 30% per hour. So, and then I need, so you have 35 milligrams of this stuff, and it decays at a rate of 30% per hour. How much of the original will remain after 12 hours? So here's my initial amount. It's decaying at a rate of 30% per hour. So that's my R. Here it is as a decimal. So I got to find my growth factor, I have to take 1 minus that, and I get 0.7. So here's my equation, an original amount, my growth factor, and again, I'm going to use T for time instead of X. So after 12 hours, well, I'm just going to go to my calculator and put a 12 in for that T. And I get about 0.448 is what I'll round it to. So how many milligrams? I have 0.48 milligrams of this stuff. And that's it. That's your review.